In this problem, we're given that the graph shown here is a transformation of the graph y equals x squared. We are to write an equation whose graph would appear as it does here, and there's a hint that there is also a vertical stretch or compression in addition to the horizontal and vertical shifts. So to start, notice that y equals x squared has its lowest point at 0, 0. Notice that our graph has its lowest point at 1, -2. So to get from the point 0, 0 to the point 1, -2, we would have to start here, then we'd have to move to the right 1, and then down 2. So to do this, we'll start with our parent function y equals x squared. To get the graph to move to the right 1, you need to subtract 1 on the input. You may think of this as we're subtracting 1 on the inside of the function, meaning that the -1 is part of the squaring process. If I were to graph this, I would get this graph moved to the right 1. Now to get the graph to move down 2, you must take this equation, and to get it to go down, we will subtract 2 on the outside of the squaring process. If you were to add 2, the graph would move up, but since we're subtracting 2, the graph would move down. So this will move the graph to the right 1, down 2. The problem with this is, you may have noticed that my graph here is really wide, parabola, whereas the one given here is rather skinny. So this means we need to multiply on the outside by some number, call it a. It turns out to get from a wide parabola to a skinnier one, a must be a number bigger than 1. However, we need not think about that now. We need only find an xy pair on the graph for which we didn't use yet. So I can pick any point on the desired parabola besides the one we've used, which is 1, -2. But as a hint, you're going to want to find a point on the graph that goes right through the grid marks. One point that's usually handy would be the y-intercept of the graph, which in this case is 0, 0. Or pick any other point that looks like it lies right along the grid line. For example, this one here looks like it's exactly the point 3, 6. So you could pick that one. So I have a choice. I could replace x with 0 and y with 0, or I could replace x with 3 and y with 6. Either way, I will get the same value of a, as long as I picked a point that lies right along the grid line. So for example, if I replace y with 6 and x with 3, I need only do a little bit of arithmetic and some solving to find the value of a. Well, 3 minus 1 is 2, so we have 2, and it's being squared. To simplify further, since the 2 is being squared, that gives you 4, but remember that the 4 is being multiplied by the a. Since multiplication comes before subtraction, I will think of this as 4 times a, and then subtract 2. Now I need only add the 2 over, which would give me the equation 4a equals 8. Since the 4 is being multiplied by the a, I would divide by 4 on both sides. Now on the right hand side, 4 divided by 4 is 1, so I have 1 times a, or a, on the right hand side, and on the left this simplifies to be 2. Since I have a equals 2, I can plug that back into this general structure here. So if I copied this exact thing down, replacing a with 2, I would get this equation, and you can check this on your graphing calculator or type this into Math.as if this were your question, and see that the computer would give you credit for the problem. The -1 inside the squaring process would move the parent function y equals x squared to the right 1. The subtract 2 on the outside of the squaring process would move the graph down 2. And then finding the value of a and replacing it here will make parabola skinnier, making it so the graph will go through the points 0, 0, and 3, 6.